guys, I'm ParvinEyvazov and I'm the computer science student at Akdeniz University, and today I'm going to talk about the machine learning and some methods of it basically. Let's start from the differences between the humans and computers. The main difference between them is that humans learn from the past experiences, but computers or machines need to be told what to do. Computers are strict logic machines with zero common sense. That means if we want them to do something, we have to provide them with detail or step by step instruction on exactly what to do. So we write scripts and programmed computers to follow these instructions. That's where machine learning comes in. Its concept consists of getting computers to learn from experiences past data. Machine learning is a tool for turning information into the knowledge. In the past 50 years, there has been an explosion of data. This mass of data is useless unless we analyze and find a pattern within. Machine learning techniques are used to automatically find the valuable underlying pattern with complex data, and we will otherwise struggle to discover. The hidden pattern and knowledge about a problem can be used to predict the future events and perform all kinds of complex decision making. American author and public speaker in the area of future studies, John Naisbitt, say that we are drowning in information and starving for knowledge. Machine learning is the idea that there are generic algorithms that can tell you something interesting about the set of data without you have to write any custom code for the specific problem. Instead of writing code, you feed data to the generic algorithm and it builds its own logic based on the data. In other words, machine learning is an application of AI that provides system the ability to automatically and improve from experiences without being explicitly programmed. It focuses on the development of computer programs that can access data and use it to learn for themselves. The primary aim is to allow the computers to learn automatically without human intervention or assistance and adjust action accordingly. For example, one kind of algorithm is a classification algorithm. It can put the data into different groups. The same classification algorithm is used to recognize handwritten numbers, could also be used to classify emails into spam or not spam without changing a line of code. It's the same algorithm, but it has feed different training data, so it comes up with different classification logic. Most of us are unaware that we already interact with machine learning every single day. Every time we Googling something, listen to a song, or take a photo, machine learning is becoming part of the engine behind it, constantly learning and improving from every interaction. It's also behind world changing advances like detecting cancer or self driving cars and etc. Let's talk a little bit about terminology and process. And let's start with the dataset in terminology. Dataset is a set of data examples that contain features important to solving the problem. And okay, what's the features? Features the important piece of data that helps us to understand the problem. These are feed into a machine learning algorithm to help it learn. And what is model? Model is a representation of a phenomenon that machine learning algorithm has learned. It learns this from the data it's shown during the training. The model is the output you get after training the algorithm. For example, a decision tree algorithm will be trained and produce a decision tree model. About the processes, the first one is data collection. In this process, you have to collect the data that algorithm will run. And after collecting data, you have to prepare it, like you have to format and engineer and data into the optimal format, interacting important features and performing dimensionality reduction. And the training part, also known as the fitting stage. This is where machine learning algorithm actually learns by showing it the data that has been collected and prepared. In the evaluation part, you have to test the model, you see how it will perform. At least in the tuning part, you have to fine tune the model to maximize its performance. After talking about the terminology, let's also talk about the backend theory. Ada Lovelace, one of the founders of computing and perhaps the first computer programmer, realized that anything in the world could be described with math. She also realized that machines had the potential to understand the world without the need for human assistance. Around 200 years later, these fundamental ideas are critical in machine learning. No matter what the problem is, its information can be plotted onto graph as data points. Machine learning then tries to find the mathematical pattern and relationships hidden within the original information. Let's see it from the probabilistic side. We live in a probabilistic world. Everything that happens has uncertainty attached to it. The Bayesian interpretation of the probability is what machine learning is based upon. We have to base our probability on the information available about the event rather than counting the number of the repeated trails. The benefit of taking this approach is that probabilities can still be assigned to rare events, as the decision making process is based on relevant features and reasoning. And yes, we come to the machine learning approach or methods. These methods are usually grouped into areas like that: supervised, unsupervised, semi supervised, and reinforcement learning. Supervised and unsupervised are well established approaches and most commonly used. Semi supervised and reinforcement learning are newer and much more complex but have shown impressive results. Let's start from the supervised learning and start with an example about it. Let's say you're a real estate agent, your business is growing, so you hire a bunch of new trainees agents to help you out. To help your trainees, you decided to write a little app that can estimate the value of a house in your area based on its size, neighborhood, and etc., and what similar houses have sold for. So you write down every single time someone sells a house in your city for 3 months. For each house, you write down a bunch of details like number of bedrooms, size in square feet, neighborhood, and etc. But most importantly, you write down the final sale prices. Using the training data, we want to create a program that can estimate how much any other houses in your area is worth. This is called supervised learning. You knew how much each house sold for, so in other words, you knew the answer to the problem and could work backwards from there to figure out the logic. To build your app, you feed your training data about each house into your machine learning algorithm. The algorithm is trying to figure out what kind of math needs to be done to make the numbers work out. As theoretically, in supervised learning, the goal is to learn the rules between a set of inputs and outputs. Supervised learning usually requires a lot of data before it learns. Obtaining enough reliable data is the hardest and expensive part of using the supervised learning. That's why data has been called the new oil. The output from a supervised machine learning model could be a category from a finite set. There's two types of outputs: classification and regression. Classification is used to group the similar data points into different sections in order to classify them. Machine learning is used to find the rules that explain how separate the different data points. Classification approach try to find the best way to separate the data points with a line. Regression is another form of supervised learning. The difference between classification and regression is that regression outputs a number rather than a class. Therefore, regression is useful when predicting numbers based problems like stock marketing, the temperature for a given day, or probability of an event. Regression is used in financial trading to find a pattern in stocks and other assets to decide when to buy or sell and make profit. For classification, it's already being used to classify an email if you receive spam or not. Both the classification and regression supervised learning techniques can be extended to much more complex tasks. For example, the tasks involving the speech and audio, image classification, object detection, and chatbots are some examples. Unsupervised learning. Let's start with our original example. You are a real estate agent again. What if you didn't know the sale price for each house? Even if you all know the size, location, etc. for each house, it turns out you can still do something really cool stuff. This is called unsupervised learning. This is kind of like someone giving you a list of numbers on a sheet of paper and saying, I don't really know what these numbers mean, but maybe you can figure out if there's a pattern or grouping or something, and good luck. As theoretically in supervised learning, only input data is provided in the example. There is no labeled example output to aim for, but it may be surprising to know that it's still possible to find many interesting and complex patterns hidden within data without any labels. Unsupervised learning can be harder than supervised learning, as the removal of supervision means problem has become less defined. The algorithm has less focused idea of what pattern to look for. Think of it in your own learning. If you learn to play the guitar by being supervised by a teacher, you will learn to quickly by reusing the supervising knowledge. But if you only taught yourself, it's hard to find, so much harder knowing where to start. Therefore, that's why supervised learning is also known as the knowledge discovery. Unsupervised learning is very useful when conducting exploratory data analysis. Semi-supervised learning. Semi-supervised learning is a mix between supervised and unsupervised approach. The learning process isn't closely supervised with example outputs for every single input, but also don't let the algorithm do its own thing and provide no form of feedbacks. Semi-supervised learning takes the middle road. By being able to mix together a small amount of labeled data with a much larger unlabeled dataset, it reduces the burden of having enough labeled data. Therefore, it opens up many more problems to be solved with machine learning. Generative adversarial networks. Generative adversarial networks have been a recent breakthrough with incredible results. GNAs use two neural networks, a generator and a discriminator. The generator generates output and the discriminator critiques it. By battling against each other, they both become increasingly skilled. By using a network to both generate input and another one generate output, there is no need for us to provide explicit labels every single time, and so it can be classed as semi-supervised. Reinforcement learning. It's a less common and much more complex, but it has generated incredible results. It doesn't use labels, and instead of them, it uses reverse to learn. In this approach, positive and negative feedback is used to reinforce behaviors. Think of it like training a dog. Good behaviors are rewarded with a trait and become more common. Bad behaviors are punished and become less common. This reward motivated behavior is a key in reinforcement learning. This is very similar to how we as humans also learn. Throughout our lives, we receive positive and negative signals and constantly learn from them. The chemicals in our brain are one of the many ways we get signals. When something good happens, the neurons in our brain provide a hit of positive neurotransmitters such as dopamine, which makes us feel good and we become more likely to repeat that specific action. We don't need constant supervision to learn like in supervised learning. By only giving in occasional reinforcement signals, we still learn very efficiently. Games are so popular in reinforcement learning research. They provide ideal data rich environments. The scores in games are ideal reward signals to train reward motivated behaviors. Additionally, time can be sped up in the simulated game environment to reduce overall training time. A reinforcement learning algorithm just aims to maximize its rewards by playing the game over and over again. If you can frame a problem with a freaking score as a reward, it's likely to be suited to reinforcement learning. And yes, thanks for watching, guys.